Hello, everybody. Welcome to our panel on disaggregating and SDN'izing RAN, promises and challenges. My name is Sunay. I'm the VP of R&D for mobility at ONF, where I oversee all the mobile projects, including the newly announced SD-RAN project. We have an amazing group of panelists today. I'm super excited to introduce them to you. Our first panelist is Chih-Lin. Chih-Lin is the Chief Scientist of Wireless Technologies at China Mobile and the TSC Co-Chair at O-RAN Alliance. Chih-Lin is an amazing researcher in the field of RAN. Specific to this panel, though, she has authored the seminal paper on C-RAN, disaggregation, virtualization, and cloudification of the RAN. Our second panelist is Lédl, who is the VP of Network Trials at DT, and also the head of 5G Haus, DT's 5G Innovation Lab. He is DT's alternate board member for the O-RAN Alliance and one of the founders of one of its precursors, XRAN. Our third panelist is Ganesh Shenbagaraman. Ganesh is the head of integrated products and ecosystems at Radisys. In this capacity, he leads integrated solutions across wireless, wired, and media processing domains and drives collaboration with ecosystem partners. He also leads the Radisys activities in O-RAN Alliance. To set the stage in our panel, I would like to do some level setting with a very short presentation. So our starting point on the path towards a disaggregated RAN is the following. We have eNode Bs decomposed into baseband units and remote radio units. The BBUs are usually stationed at the base of the antenna where the RRUs are mounted. The interface on which the BBU and the RRU communicate is vendor specific. Further, every vendor has its own monitoring, logging, configuration, and control platform that they further tailor to different operators. Different vendors have different capabilities on this front. Again, using vendor-specific interfaces, the RAN is integrated into operators' OSS/BSS platforms and optionally SON platforms. So starting from that, we aim to disaggregate the RAN in two dimensions. In the first dimension, we disaggregate the RAN stack into RU, DU, and a CUPS-compliant CU. The open front haul interface between the RU and the DU has been developed and is being maintained by the O-RAN Alliance, and the F1 interface is a 3GPP specification. In the second dimension, we SDNize the RAN by introducing the near real-time RAN Intelligent Controller, or the RIC. This is a platform that allows control and configuration applications called XApps to interface with the disaggregated RAN nodes and assert control using an O-RAN specified open interface called E2. Up north, we have the O-RAN specified open A1 interface connecting the near real-time RIC to its non-real-time counterpart, and the open O1 interface to connect all RAN nodes, including the near real-time RIC, to the operator's orchestration and management platform. If we are discussing Open RAN today, it is thanks to the operator's initiative in forming the O-RAN Alliance. O-RAN was formed by joining the forces of C-RAN Alliance and XRAN with the mission to develop specifications for open interfaces. We also have a number of parallel and overlapping communities towards this same goal. Under TIP, we have initiatives that aim to develop open hardware specifications. We have O-RAN software community, where the community is developing open and closed software components for various parts of the O-RAN architecture. And finally, we recently have formed a community in ONF for the SD-RAN project, where we are developing an open source platform for the near real-time RIC and a number of XApps, open and closed by the community. These groups are starting also to collaborate since the goal effectively is common. the open source communities are starting to share code, and all the groups are sharing experiences that influence how they approach to the problems that they're tackling. Most importantly, though, these groups are now feeding their experiences and associated recommendations back to the ORAN Alliance, which is where specifications are studied and accepted. Now let us go back to the ORAN architecture and set the stage for today's panel. When we start thinking of how to implement the ORAN architecture, we deduce that the CU, the near real-time RIC, and the XApps will all be realized in software and run on a distributed telco cloud. For certain scenarios, we can even include the DU into this list. And each of these components actually have distinct subcomponents. For example, the CUC will have components responsible from controlling the mobile link through radio resource management, components responsible from interfacing with the external nodes, the mobile core and other E2 nodes, as well as the near real-time RIC. According to 3GPP and ORAN specifications. So one could potentially imagine realizing them as microservices. So then in this decomposed view, the RAN control is dispersed across the different nodes in the architecture. So since one of the overarching goals is potentially a multi-vendor deployment, this will effectively mean distributing the control of the RAN across different vendor solutions. While there is a somewhat clear demarcation between the types of control for some of these components, either from exact control functionality or the delay loops, the line gets somewhat blurry for some others. So how we achieve the level of disaggregation, programmatic intelligent control in a multi-vendor setting is one of the main points I would like to cover today. So now that I have such an esteemed group of panelists in front of me, I have a ton of questions. So let's proceed with that. All right. My first question actually is to Chih-Lin. As I mentioned, you wrote one of the seminal papers on the disaggregation, virtualization, and cloudification of the RAN and called it CRAN. What drove you and China Mobile in the first place to pursue CRAN?
Okay, thank you, Oz. And first, thank you for that nice lead-in presentation and set the stage for all of us. But I have to say that our pursuit through CRAN to ORAN actually has been going on for almost 10 years now. As early as 2011, I think we had already recognized the one thing that is our industry needs to be not only as efficient as possible with the resources, with the spectrum, but also we need to gain agility. We need to become soft. Now I believe it's a global consensus because as you can see that the 5G standards, it's really very much a both efficiency and agility driven solution, starting from the core network to the access network and also to the air interface. They are all very much a configurable centric philosophy. But in the early days, when we started the CRAN initiative, we were primarily looking at first, how to be really power efficient, how to be green, and also how to be cost effective, to be resource efficient. So if you remember the kind of distribution of the power consumption in our system, would say that maybe 70–80% of power consumption is in the access network. And then in the access network, maybe the base station part, I mean, probably half of the power consumption used to be spent for kind of air condition and other environmental control of the base station housing of the baseband unit. So if we can start centralize the baseband unit, that's the first stage of C-RAN, as you can imagine. We can actually drastically reduce that part of the power consumption. And then once we centralize it, we should be able to pool the resources so that we can have statistic sharing, resource sharing across multiple sites. And moreover, you shouldn't stop there. You could start contemplating the kind of data center approach of massive resources, the virtualization, cloudification. So all these three steps we call centralization and the collaboration, and as well as the cloudification, were different phases of what C-RAN initiative was driving at. And it was a easy peasy when we applied that to, at that time, the existing network, namely the 2G and the 3G. But when we started applying it to 4G, we immediately bumped into a big challenge of, in those days, the front haul bandwidth requirements. So that then triggered us to start investigating the now, I think, ultimately, the front haul, mid haul, and back haul, different partitioning of the baseband processing. And we have, like, I think, 8 major options there. And finally, I think 3GP had taken one of the options to be basically the mid haul between the CU and DU. And then the CPRI has progressed into eCPRI, is the famous front haul that provided the flexibility and the configurability of the RAN, making it, I guess, SDN'ized, or at least possible SDN'ized. So both green and soft, meaning the efficiency and agility, was basically the main value that the C-RAN initiative was striving at in the beginning. And then I think maybe by 2014, 15, when the big data analytics came into fashion, and then the AI machine learning came into place, we evolved into the open and smart, which actually is the main, I think, theme today for our community. And this is, I think, a new era, starting from 4G going into 5G, and now from 5G to 5G plus and beyond. I believe this effort is going to be a main thing, and there will continue being lots of opportunities and challenges that we all can be working on with all the passion and the excitement as we are today.
Thank you, Chih-Lin. Peter, similarly, DT has been super active in this field very early on, first with XRAN and now with O-RAN Alliance. What were the goals initially for DT to be part of XRAN, to be one of the founders of XRAN?
So from our side, the motivation in order to get engaged and also initiate activities that led to the new architecture design and interfaces specification is really to create much more flexibility in the RAN solutions. And obviously the flexibility can be seen in many different domains. So one of the domains can be on the solution provider level. The other flexibility can be on the service level. So how the services are implemented in the RAN solutions. And in particular for 5G, for example, really, if you look at the technical constraints that we see today, the traditional one are really availability of sufficient backhaul, front haul. It is enough coverage. It is energy efficiency, as also Chih-Lin mentioned, but also some of the regulatory constraints. So these are the typical constraints. But one of the constraints that we saw at that moment is in particular flexibility in the RAN solutions. So to find the tools that can increase this flexibility is one of the motivation, and get industry aligned around these tools. So specification of the open interfaces internal to RAN is clearly one of the enablers for the flexible RAN solutions to be developed and deployed. And there, obviously, open front haul interface has been the prime interface that the organization and alliance worked on. The other flexibility, especially in the context of service level flexibility, how can RAN act differently according to different services need, and how to reconfigure that during the lifetime of a connection. So this really called for some of the key architectural components that were introduced in this effort. And one example there, and the result of it, was the introduction of the RAN intelligent controller, which you mentioned in the introduction, and is really an important characteristic of the RAN compliant architecture, having an ability to interact with the service management and orchestration on the northbound side, and that brought the open A1 interface into the architecture, and take the policy intents through this interface, and then allow the architecture to instruct the underlying RAN infrastructure via, again, newly introduced open E2 interface, creates a possibility to program the network according to the service needs. So for us, it was really flexibility in different dimensions that were our main goals.
Great, thank you. Ganesh, Radisys was also an early believer in open and intelligent RAN. Actually, as early as 2017, I remember Radisys and ONF jointly demoing operation of an ONOS-based XRAN controller, which was the precursor to the near real-time RIC, and a few applications controlling the Radisys LTE stack. What made Radisys as a vendor a believer in this paradigm?
Thanks, Haus, and thanks for the presentation, and nice to be in this panel with Chih-Lin and Petru. So to answer your question, the roots of Radisys, the group which creates all these wireless solutions, we've been in this business of protocol software stack development and licensing for quite a number of years, more than 3 decades. So mostly we rely on the standards, the open standards, to develop our software stack solutions. And we've been following the trend of the industry ever since we had forums like, in addition to 3GPP, forums like Small Cell Forum, we were one of the early members. And later, when ONF was formed, we were part of the COD initiative as well. Right? And we are, of course, one of the early members of the XRAN program as well, XRAN forum as well. So we've been very actively tracking, seeing the changes in the industry. So we participated in some of the interface definition efforts as well in XRAN especially. And when the XRAN controller based on ONOS was available, we had our eNode we integrated, and we could showcase this in a few trade shows, mostly MWC in Barcelona and MWC Americas. And this gives us a clear view of how to do our software implementation in a vendor neutral, platform neutral way, so that it can interwork with other third parties. That has been our core business. Right? And it makes us align with the evolution of the industry as it changes. And we've been seeing these changes coming in from 4G days and picking up great momentum in 5G. So our association from XRAN to ORAN and ONF, everything continues.
Thank you. We've already started talking about the ORAN architecture. So the ORAN Alliance is on the path to specifying open interfaces for the disaggregated architecture that we're all trying to get to. And there are early successes already. I would call on, as Peter and Chih-Lin mentioned, on the open front hall to be a very important milestone on this front. Since the initial completed specifications that we have are on this front, really, do you see the first phase of the disaggregated RAN deployments to be focusing on mainly the RU, DU, CU split initially? So this is a question for all of you.
Okay, I'll take a shot first. I think very likely because actually this CU, DU, RU are with the both the mid-hole interface F1 from 3GPP between CU, DU, and then the kind of the industry standards or now being perfected and comprehensively way by ORAN Alliance, this open front hole interface that provides the opportunity to have probably 1 to M and 1 to N relationship from CU to DU and then from CU to RU. However, it depending on the implementation or realization scenario that you could be co-located CU-DU or you could have co-located DU-RU. I think all the, while different deployment needs will require different configuration, we need to make sure that these interfaces in these two, the mid-hole and front-hole, are truly comprehensively defined so that it would allow opportunity for multi-vendor mix and match kind of solution being composed and delivered, which could embrace much broader participation from our ecosystem, much more players. And in a way, I believe, like you say, ORAN Alliance has two main things: the open, which address to open source software, open reference design hardware, and open interface, open API to start with. And then the smart or the intelligent part definitely is featured by the two RAN intelligent controllers, the RICs. I believe the first availability in the market you will see in all the possibilities will probably be as what you have just described. This primarily, I think that the first out would be the front hole interface-based disaggregation, decoupled offering. And you know that we have the open reference design, aka white box effort as well, paired with these key open interfaces. And the first phase is really indoor picocell based on the open front hole specification. And specifically, it would go from an option of the traditional configuration with such open interface so that you can have vendors of the DU being different from vendors of the RU. And then the phase 2, we will be working into the outdoor macro cell arena. And then finally, phase 3, I think there will also be outdoor microcell options being offered. But all of this, you will see a common thing is around the open front hole interface. But I might add that the first open front hole interface specification that ORAN Alliance has delivered to the community is based on a particular lower layer split, which is option 7-2, namely EC base. But we are seeing also in some of the different deployment needs where option 8, which is close to the traditional C3, as well as option 6, which is, like Ganesh mentioned, the small cell foreign, the FAPI interface, may have greater demand as well.
All right, thank you. Petra and Ganesh, before you answer the same question, maybe let me add, based on what Chih-Lin just described, an additional angle to this. So while you describe this, also, can you let us know exactly how you envision in this disaggregated scenario, operationalizing a multi-vendor solution inside an operator? Is there a need for systems integrators on this front? Or do the operators really want to tackle this on their own with a DevOps team? Anyone?
Sure, I can start. First of all, I would also second Chih-Lin's point on the importance of the open front hall. So that's what we also see as the really early deployment opportunity in the Open RAN solutions. The angle I'd like to offer in this context is also it is attractive because it offers a kind of balanced investment in the two components that are disaggregated, and also in the really softwareized world when the processing is really cloudified and virtualized. We expect to see also a different life cycles and different lifetimes of the components in the network. So the disaggregation in that point make a lot of sense and is attractive. And obviously, the associated question that is on the complexity side is, of course, how you operationalize and how you manage that system. So there can be definitely different approaches to that. And I believe that we would need to take more responsibility than in the past as operator in integrating and managing these solutions. And eventually, also important component of the solution would be introduction of the independent management frameworks.
So I would agree with both Chih-Lin and Petr on this. From what we see as a vendor here, the interest level, which we can gauge from the number of RFPs, which we see the trend in the RFPs, it's a great surprise. When I say great surprise, the momentum which the ORAN proposed disaggregated architecture has caught on with all the operators globally. I would say we can see a very, very clear trend and momentum towards splitting the CUDU and RU. And like Chih-Lin mentioned, the deployment option or configuration can vary a little bit based on the actual use case and the deployment scenario, combining the DU and RU or co-locating the CU and DU, such things. And there's a clear trend of disaggregation, and that's a strong indication or a pattern in all the RFPs which we have seen. That is point number one. Second, the question you raised was about the systems integration and the need for it. I think it's inevitable when you are talking about a multi-vendor scenario. And what forms the basis for integration? That also is something that is evolving or emerging. The IoT specifications published by ORAN like organization are a great start, but there is more work beyond the IoT specifications as well. Right? There has to be a certain level of expertise in the system integration in RAN. And that landscape is still emerging, and there are players jumping in to do this job for the operators. And the third point is the operators themselves are readying for this transformation. The kind of RAN deployment, the installation commissioning to the operationalization of the RAN is changing dramatically with the amount of softwareization that is happening. Right? I see that operators are equipping themselves to prepare to handle this kind of operation. And the final point is about what Petr mentioned, the transparent and centralized management of the nodes being enabled by a clear definition like the OWN interface should make it seamless and consistent for operators to adopt this approach. And network management, rather than being more fragmented and proprietary, can become more streamlined and uniform. And I think that's where we are heading. And that's another important dimension of how the disaggregated networks will get deployed.
Great. Thank you.
And the gentleman, I would like to jump in and add some perspective also about this multi-vendor
Sure.
era that we are all driving into. Definitely, I think after we disaggregated the end-to-end system, we gain the flexibility, we gain the agility, and we gain the opportunity of benefiting with a diverse set of expertise that may come from different players who are particularly good at a particular aspect of software or particular subset of the hardware. But with that benefit, yes, we have created to ourselves a new challenge, which is end-to-end integration. Now, while we hope, okay, as one of the major vendors, we hope one day we will all become fully capable and be able to operate on daily basis the DevOps mode, so that we can ourselves take the care of the complete end-to-end system integration challenges by in-house. But personally, I think that's gonna take a long time to come. And definitely, we also shouldn't aim at that mode of operation like in a hurry. So for a long time, I think we will need the help of expertise of third-party system integrator. And I would also mention that I think that set of players certainly includes newcomers, but moreover, it also includes the incumbent major traditional vendors, because they are probably the house that has very good end-to-end knowledge. So we will need a lot of the system integrators, so that I think it will include the new player as well as the incumbent player. And that will be a tremendous value for the overall ecosystem. And one more thing is, Rural Alliance actually are very attentive to this aspect of the community needs. So not only, in addition to our 9 working group, we have one of the 3 focus group is focusing on testing and integration, the TIFG. And this focus group is working on, of course, with all of members' help, working on end-to-end testing framework of a ORAN system, and also working on subsystem, minimum viable solution type of IoT, or as well as a compliance test. And moreover, ORAN Alliance is working with the global community while we are talking, setting up different regional OTIC, Open Testing Integration Center. Peter is actually coordinating the European region's OTIC effort. And here in Asia, we actually, both in China, in India, in Japan, there are multiple sites of such facilities set up. And in the US, of course, needless to say, there are quite a few that's being planned out. And the early actually emergence was November last year. We already had kind of the launch of some of these OT facility, as well as the first global PlugFest that was held with on site of these OTIs. And this would be infrastructure that's provided to the global ecosystem to come and try your latest, the newest piece of software or hardware, and to see if it can be easily integrated with other vendors' solutions, but aligned with ORAN Alliance's spec. So we are actually trying to set up this kind of infrastructure for our global community to kind of incubate also the new system integrators, so to speak.
Great, thank you, Chih-Lin. So let's start talking SDN. So the second phase then of the disaggregated architecture deployment will bring in the near real-time RIC. And here we're talking about third-party applications leveraging a controller platform to control and configure deployed RAN components. Do you envision, when it comes to deployment, this to be more difficult than the first phase? And if so, what are the major challenges that you see in this phase going towards actual deployments?
Would the gentleman want to go first?
I will take a quick take on it, right? So I think the easier ones will be the reporting or observing type of XApp applications. They will be easier to manage, deploy, right? The more troublesome ones are going to be the controlling type of XApps, which are modifying the behavior of RAN through some logic or some artificial intelligence logic, whatever, right? So that part, there has to be sufficient level of definition to allow interoperability end to end and even interworking among XApps. So that amount of work is a prerequisite for these XApp deployments to be working well in the real life deployments, right? So that is something, there is a lot of work ahead of us, I believe, both from a standards point of view, implementation, and seeing the interoperability on the field in trials and so on. So I think that is some way away, but definitely possible, but groundwork needed is a significant amount of work there.
Okay, Peter, I jump in, or are you?
No, Chih-Lin, go ahead.
Okay. I think, yes, the controller, or actually the RAN intelligent control, the RICs, in the O-RAN architecture, we actually have currently focused on two pieces. One we call it the non-real-time, and then the other is near real-time, which respectively are functioning with a control loop of 1 second above, versus maybe 10 milliseconds and up to 1 second, more or less in 100 millisecond, the control loop range. We actually also might have closer to real time, which is below 10 millisecond control loop range. But right now, I would say that because the non-real-time RIC, we are envisioning it to be the one that performs the function more like an offline training. Okay, so to update the machine learning and AI models, for example, whereas the near real-time RIC would be the one using those models and some enhancement information to facilitate the new type of control, potentially providing more intelligent, more dynamic, more fine-grained optimization in mobility management, in resource management, in cross-layer user experience optimization. There are many, many functions that we can think of, okay, that we call XApps that sit on the kind of RIC platform. So very importantly that we would need to make sure the specification of the RIC platforms is comprehensive enough that it provides the right interface, provides the right support functions such as conflict mitigation and others, and provide the necessary temporary databases that would be needed locally. Then for the XApps that are actually the various control functions apps, we would like it to be a broadly available opportunity to third-party developers, or fourth-party, or anybody who has some good new ideas. And as long as they follow our spec, they can use the right set of common APIs or interfaces in the right way. Then they should be able to be hosted on anybody's RIC that's developed following O-RAN RIC spec. And in that realm, I believe that actually we will see probably the injection of the non-real-time RIC capability first, because there, because of the longer control time in the control loop, and because of its affinity with the existing FCAPS OAM functionality, as well as affinity with the now well-known nano functions for a cloud platform. I think there are a lot of synergies that that three parts can kind of work together, and bringing in more initially in the management domain enhancement to our network. Okay, a lot of people are looking at some of our early stage prototype functionalities, such as energy saving, such as anomaly detection, root cause tracing, and more optimized dynamically equipment configuration. So those will happen first, and we will benefit from the non-real-time components of the rig first. And the near real-time rig, I think, is the real crown jewel, and also is the one that has the most challenging in terms of technical readiness. And but I'm very happy to see that we actually have multiple tracks that are trying to deliver such solution. Of course, the ORAN and the Linux Foundation's joint open source community of ORAN is developing a set of solutions, open source there. And thanks to ONF, ONF is also taking a crack at it, and from what I can see, it's moving very fast on that track. And also, I might share that we have some other partners, vendors that are also developing theirs. They may or may not be open source, they might be proprietary, but as long as these rigs developed are all following ORAN spec, I think it would accomplish the ultimate goal, that is any XF developers or RF or non-real-time rig developers can see that their app can be hosted across different rig platforms that's developed by different entities.
Thank you.
Okay.
Peter?
Thanks, thanks, Oguz. I think that from my perspective, I especially agree to what Ganesh mentioned. But to start with, I truly believe in benefit of the rig approach and the XApps approach. Of course, there are XApps that are easier to deploy, mainly the monitoring one, and XApps that would be more difficult because of potential conflicts resolutions that need to happen in the system. But I think important is that it is a approach that should embrace all the AI and machine learning capabilities and bring actually any innovation fuel into the RAN solution development. Obviously, from the adoption perspective, the situation is still a little bit different compared to, for example, open front hall discussion, where we already have an ecosystem of players developing RUs and developing the UCU solutions. For the RIG and XApps, that's a completely new environment that we are creating, and for that we need to see the RIG platforms to get adopted, matured, and also embrace and improve the E2 advanced specifications. And that's also why it is so important that we see efforts in ORAN open source community, as well as in the ONF community, developing the RIG platforms that really creates an environment for new opportunities in really algorithmic space for the XApps development, and that opportunity is there to be picked, and we very much support that these initiatives.
Great, thank you. So a couple of quick follow-up questions on this, because I think you somehow already answered or hinted at these, but I wanted to make them explicit. So in this near real-time RIC phase of deployment, the quick question is: operators have traditionally used big vendors in the RAN space. Should we expect, or should we even encourage, smaller companies or even startups that just focus on specific XApps? And should we expect operators to actually find place for such solutions in actual deployments moving forward?
Let me just say this. I think the new ecosystem that O-RAN Alliance has envisioned for the future will have many more new players in jointly together to do a lot more. Okay, so it's like the old saying, make the pie bigger. Okay, it's not like we are getting more people to come share with this big size pie.
Yes.
So definitely we see the need to have new players, large or small, okay, any size. And the fact is that with the kind of the effort that our alliance is focusing on, pushing the boundary of intelligence and openness, we are actually lowering the technical barrier, the entry-level barrier for new players. For example, case in point, the open reference design hardware platform, the white box, it provides a default starting point for new players to come in, and they can start from there and then see if they have a particular brand new idea of a new software, new algorithm. They can be their differentiator on their offer. If they have a special new piece of device or material that they can enhance the hardware side, that could be their differentiating value. So everybody will have an easier time to bring in their expertise and their differentiating value with the lowered technical entry barrier. I think that's one thing. It's just like on the software side, we are counting on the great contributions from the open source community, be it the Linux Foundation, the ONF, or any other, because we believe that open source is also a great kind of starting point for more new player to come in, to add on their own piece, right? You have a much easier time for a new entrant. And also, I believe our industry, wireless communication, one of the keywords is diversity, right? Why do we want more new players? Because diversity brings new life. Diversity brings the best ultimate value eventually in terms of performance, in terms of cost effectiveness. And definitely, we think a diverse, vibrant ecosystem is something that we're looking forward to, and that includes existing incumbent players, new players, major large vendors, not just traditional telecommunication vendors, but I think IT industry vendors as well, and as well as the small, medium size, any size and shape. That is the future that we believe will be exciting for all of us.
Excellent. Maybe as a follow-up also, since Chih-Lin mentioned, what role specifically do you see for open source communities play in this paradigm moving forward? Are they good starting points, or potentially is there room for them even in deployment? Where do you see open source play?
Well,
maybe we'll start with
who will try first? Okay, I'll try first. I think one, it's a great starting point to help many more newcomers to join in. And two, definitely, I believe also for operators, it's where we can start trying some, the alpha, the first kind of version of a new functionality or a new subset of the system. And even more, I think more importantly, I personally believe, I sometimes in many occasions, I'm talking about ICDT deep convergence, but let's put the DT aside. The DT is basically data technology, which is the machine learning, the AI aspect, the intelligence side. But in terms of IT and CT, I always see that from very early days, we talk about ICT convergence, like even in the 80s and 90s, but never converged. I always tell people that has always been a lie. But really, the ICDT, IT and CT start converging post 4G, okay? On our way to 5G, that convergence is happening. And there is a very interesting thing that we need to notice in this convergence. It's not just the technology per se, it's also the approach and the philosophy. The CT, what do we do? Things like 3GPP and the proper official SDOs, we do things very, very carefully, very, very cautiously, in a way almost very conservative, okay? And take a long time to come up with a new generation, okay? Or new release. And our system are so optimized end-to-end, so tightly coupled, we take years to have a new release, a new offering, okay? We know the famous generation is 10 to 12 years per generation. And even the fractional generation, the .5, the 0.5, the 0.75, and those fractional generations also takes years, okay? And how about IT industry? It's software-centric. That's why it's important to softwareize, right? And they go not by years, not by months, sometimes not by weeks, maybe days, or even the morning, afternoon, you have 2 different fractional release coming up because it's soft. And also, I think, also in IT industry, open source community has been a major resource and also the energy level, where open source community's approach is, who cares about standard? We write the code and it works, then it's de facto standard. Okay, I'm not saying that the future should only be open source software community approach, but I believe the right balance between the two philosophies, okay? One is super, super fast and agile. The other is super, super careful and thorough, and until you have the ultimate thing. I mean, one thing we can say that CT side is function not so important. It's performance. If you don't have the ultimate how many number of nines performance, no new functions, okay? But IT with open source software community, what is it? It's function first. And we throw the function out, then we can underrun, improve its performance until it eventually gets to a great level that people can agree with. But how can we find the right balance between these two approaches? I think this is something that I'm looking forward to see how the open source community now in the ICT convergence effort is only to come in play major role also in the CT community, how it's going to impact our proper official standards work. One case in point, okay, some say ORAN Alliance is a standard alliance, but yeah, we try to provide kind of the de facto industry practice. You can call it standard, but we already see that we launched our open source community officially April last year. We already released 2 releases, the Amber and the Bronze. The Bronze was released in June. And by the end of this year, we will have a 3rd release, the Cherry release coming out. And we are trying very hard to sync up the step between the open source community's code development and the specification delivery from the working group. So ideally, you should have the working group with the standards all fully ready. Then the open source software community of ORAN would write code to implement it. But right now, it is actually interactive because in some cases, the open source community are moving faster. So we are benefiting from their experience and their knowledge, and feeding it back to our working groups standards development work. So I already see in this case the kind of impact that we can expect in the future that open source community can bring to the standard development community. I think now it's just with ORAN, and who's to say that in the future a broader open source community will not have some kind of impact to influence even standard body like 3GPP. It's possible. Maybe not, may not happen this year or early next year, but it will happen eventually. Yeah. So that is my wildest expectation of open source community.
Ganesh, Peter, do you have anything to add?
Yeah, I have something to add to it. We also participate, Radisys participates in the open source development. And the point made by Chih-Lin, I think I would view it this way, right? Like earlier, open source in RAN was unthinkable and was thought to be undoable. I think that myth or dogma is gone, and we have got 2 releases in ORAN open source community. There are other open source development activities as well, mostly in the core network and some of it in the RAN now, right? But ORAN open source community happens to be one of the most dynamic, the most recent one, right? And the part which is interesting and which can be a game changer here is the entry barrier, which Chih-Lin talked about in reference to the reference designs in the hardware side. A similar thing is happening or going to happen, let's say, in the software side too. We are lowering the entry barrier to the people who have good ideas, good intention, the ability to bring algorithms and clever stuff to RAN. The entry barrier is being lowered because we are making a little bit of a platform available, making it a more level playing field. Individual contributors, people in the academy, universities, and other forums who have an entry barrier otherwise to something very important in the RAN space. They are now finding a channel to do this. We already see some active interest from some quarters of the universities across the globe in the ORAN-based open source work. And as a projection, or I would say a conjecture, as an extension of what Chih-Lin said, what if this takes so much momentum in the next few years, we incubate, curate ideas that goes into even 60 possible. Thank you.
Oh, good. The only thing to add from my perspective also here. So we clearly see the increasing role of open source in RAN, as Ganesh mentioned, and it's inevitable, especially in the areas of management and orchestration, as well as RIG development. Clearly, are areas that we are very happy that we see that development, and also creates an opportunity to really shift the focus from really volume development to core, which is the algorithms and ideas that can run on top of that those platforms. So it's really great to see from my side.
Wonderful. Maybe next, let's dive into the XApps in this architecture. So I have a couple of questions that I'm going to bundle into one. What types of XApps do you envision deploying? In other words, if you had a magic wand, what would be your dream architecture, and what part of the RAN control would you want to see as XApps running on near real-time or non-real-time RIC? And on that context, ORAN Alliance, along with the open source communities, we're starting to look at the open APIs. What is the, for XApps, what is the real importance behind that? In this scenario, how are we going to manage, again, the multi-vendor deployments?
No, I think I can start off dreaming in this in the sense you put it. I think one of the challenges, of course, there always is with the open approach is how do we manage performance and efficiency, and that's in particular important for us, so that when we deploy a solution, we have the performance at the level that we need. And obviously, in today's world, a lot of the performance is coming from that tight optimization of the large system that we are deploying. So if I would be encouraging the community, it's really look at the ideas that can create the performance of a solution that we see from tightly optimized systems by really using clever ideas, MI, machine learning, interference management, resources allocation and utilization, such that we deliver on the performance and efficiency. Similarly, really energy efficiency. So that's one of the largest cost blocks we have when we operate the networks, and it is important, and also it is necessary that we find solutions how we make these solutions energy efficient, not on the level we have today, but even better than we have today. So this would be my wish, my dream for the XApps that can deliver that.
I have a long list. So does Ganesh want to go first?
Yeah, I'll be shorter in my update. Right? So I think the power of XApps to control different dimensions of the RAN behavior, along with something like network slicing, which is inherently present in 5G as a feature, right? So I think it gives a lot of opportunities to control and offer differentiated services from an operator point of view. I think that's going to add great value and change the way the network is going to deliver value and monetizable services for different OTT services, right, and different verticals. So that's the impact we're going to see, the power of XApps plus the underlying network slicing kind of feature.
Okay, as I said, I have a long list in the sense that actually we, as early as 2014, 2015, we in-house developed a multi-red energy saving system, software only, with one regular server plugged into one of the regional NOC. It can manage 2,000 to 4,000 cells, okay, in a way that it is a mixture of 2G, 3G, and 4G, all mixed together as one system. We can optimize its configuration across the three systems to operate in the most energy efficient way, okay? But in those days, we used kind of ad hoc heuristic algorithms that we developed. But slowly, as I said, it was 2014 to 2015 time era, we had the first version. But then we had release 2.0, release 3.0. The upgrading path was bringing in big data analytics, then bringing in eventually machine learning models, the AI approaches. And so in each of our 31 provincial operating companies, at the provincial level, we have kind of provincial brain using this software platform to configure once every 15 minutes the parameters of the cells, so that we minimize the power consumption throughout our network. And that certainly is like a harbinger of what the intelligent controller can do eventually for our network. And nowadays, we are expanding this approach to anomaly detection, to fast, more dynamic, more real-time root cause automatic finding, and to traffic steering, or couple, sometimes you can call the traffic steering is something that can be interpreted as for load balancing, for interference management, or for mobility management, or for access control. And then definitely the network slicing, in how you carry it through the RAN, okay? Because right now, the clear definition of network slicing is pretty much a story of the core network and then up to the edge. But how do you carry this through RAN? I think the RIC will play a big role there. And then I already said earlier, with the machine learning AI capability in RAN, we can offer the bandwidth prediction, the channel condition prediction, as well as the application identification, so that we can truly optimize user experience, the QoE, so to speak. And moreover, further down, as I said, that we are right now focusing on the non-real-time version, the near real-time version of RIC, but we are also exploring the more real-time part, where you actually can go directly to the physical layer. For example, the MIMO parameter configuration, the massive MIMO base station parameter, and even the MCS mode selection, the modulation and coding option selection. So all across all the layers, across different time loop durations, there's a lot of the things that we have dreamed, not dreamed, I think will be realized through this RIC, this controller. And all of this certainly, I think, would be very much essential and differentiation for us to offer differentiated services to the large variety of vertical industries, because different vertical industries have very different needs in terms of their KPI, their KQI. So with this intelligent RIC in the RAN, we can offer much more close to home and much more tailor-made and dynamically match their needs. So I think I said a little bit earlier in today's session, RIC is really going to be the brain of the RAN. And hopefully it can work well with the brain of the core network, so that it provides really a total end-to-end optimization, both for performance and for efficiency, for cost effectiveness, and for ability of any new requirement and new needs that a new user or customer may come up with. So that's RIC.
Thank you. I have one last question before we close it for today. Every time I read on blogs or media about RAN disaggregation, it almost appears that the main motivation behind it is cutting costs for the operators. And today we have really discussed that the primary motivation is definitely not that, but it is much more. So let's spend maybe a few minutes clarifying that for everyone once and for all, that we are here not just for that, but there is a lot more that the disaggregation and SDN'ization brings.
Okay, I'll try to be short and brief. You can associate with the idea of cutting costs to being efficient, right? Efficiency. Definitely, that is one dimension of the value we see that we are driving the future system to. We need to be much more conscientious about the efficiency, okay? Power or any other resources, spectrum, and real estate even. But I think more importantly is, in addition to cutting costs, is increased agility, increased flexibility, increased diversity, increased intelligence. So all this will eventually enable us to both serve the general public, the 2C market better, and enable us to really be able to match up to all of the different verticals, whether it's transportation or health, medical, education, or I don't know, even smart cities, the smart grid. All of them have very different needs. And how do we build 5G in a way that it fulfills its promise of being simultaneously a more powerful horizontal platform for us, for general people like you and me, and as well as multiple set of vertical platforms, or you can call it some sort of a slice, and each address the different needs of a different part of our society that enables a transformation of our life, transformation of the way we work, and transformation of the way we live, and even transformation of the way our society is governed, is managed. So I think it's really not just cutting costs.
Thank you.
No, from my side, August, of course, we cannot ignore economics. Although we would like to sometimes, it's not possible. The angle I would bring is that when we started 5G discussions, we have always been saying that 5G should not be just another new air interface, and it needs to be a platform that can deliver all these different type of services that people were envisioning, and especially addressing also the industrial needs. And the way the networks were designed, developed, and deployed initially to deliver voice, right? It was very well optimized for that. Later, then for the data in the consumer segment, and now we, of course, with 5G, we were coming to a point to deliver all these variety of different services, and that's the point. The way we would do it, if we would continue doing it traditional way, it would just not be economically possible. So going towards a platform approach, open and flexible, also brings the opportunity to provide these services in an economical way. I would not call it like a cost cutting, as you say, but of course we cannot ignore economics of introducing new services.
Cost effectiveness.
So I would like to add a few more points. Basically, the hardware software decoupling that's already happening is really a benefit, and then with the disaggregation, I think more component players are coming into picture, and I think this allows, and there is a healthy competition which can drive the cost a little down, but it also allows the best of the breed solutions to come in. Whoever is best in certain aspects, they can bring their best component, best part of the network RAN component to the deployment, right? That way it's going to be a healthy coexistence of the best of the solutions possible. That's the one way of looking at it. The other dimension is the flexibility and intelligence aspects, that the amount of control it gives to the operators and who is deploying the network. That's going to make the network more dynamic and suitable to evolve as the demand changes, the consumer usage pattern changes, new services are rolled out, OTT and operator offered services, right? I think if we build enough flexibility and allow innovation to happen through a platform like RIC, and that's the best way to future-proof the networks. I think that's what is happening through the Orange disaggregated architecture. That will be my take.
Thanks, Ganesh. Chih-Lin, Peter, Ganesh, this has been a lot of fun. Thank you so much for enduring all my questions and answering them the way you did. Any last words?
Thanks a lot.
It's a pleasure to be here.
Thanks
for having you all. Thank you.
Thank you. Bye.